Valid parentheses. That's what we're going to solve today from Leetcode. It's considered easy. Let me just press like. I feel like I have to. So, given a string S containing just the characters left paren, left curly braces, right curly braces, left bracket, and right bracket, determine if the input string is valid. An input string is valid if open brackets must be closed. So there are two conditions, right, of its validity. First is open brackets must be closed by the same type of brackets. And second is open brackets must be closed in the correct order. Okay, so there are two conditions that we need to think about. First is we need to think about the type of it. Second, we need to think about the order. So type should match and order should match. Let's read the example. Left paren, right paren. Okay, that's true. What about the second one? Left paren, right paren, left bracket, left curly, right curly. True. Again, as we can tell here, both of the order and type seem to be considered correctly. That's why we are returning true. Third of all, left paren, right bracket. The type doesn't matter. The order, even though it was important, it was correct, so it's returning false. Left, right, but still the order doesn't matter. Order is incorrect, so it's returning false. The rest of it is left paren bracket. Okay, so let's look at the constraints. The length should start from 1 to 10,000. String S consists of parentheses only. So these are only the 6 only inputs that we're getting. Okay. There seems to be a lot of show hint, but I'm gonna choose number 3. The stack data structure can come in handy here in representing this recursive structure of the problem. We can't really resolve this from inside out because we don't have an idea about the overall structure, but the stack can help us process this recursively from outside inwards. Interesting. So we're going to use a stack, meaning that stack is the data structures in any languages that it's called first in, last out. Okay? First in, last out, meaning if you think about the trays that you are eating or having in your catering services or in your school cafeteria, every time the person who's helping out this manages trays and stack it up, once you stack up the first one, whatever the tray is gonna come out at the last. Anyhow, what I'm gonna try to do is we are gonna use whenever we have a hunch that we have to differentiate on the left side of paren, which is supposed to start first, and then the right side of paren, parentheses, right? I'm gonna group them each other. But how do we group them? I'm gonna use a dictionary. You can call it whatever you want, but I'm gonna call it maybe like a match pattern or match equals as, okay, so there's gonna be 3 pairs. If I see, let's say, the right paren, then I'm gonna look up, or I'm gonna take that as a reference to find the left paren, and the right curly braces, left curly braces, and left bracket, right bracket. I'm gonna find it as a left bracket. Okay. So what I'm gonna try to do is, as we loop through this string, once we hit or see the right paren, we're gonna check, hey, is the value of right paren, which is left paren, already there? Then we're gonna pop that from the string, and then we keep doing that. When we see the match, pop it. When we see the match, pop it. When we see the match, pop it. So at the end of the day, what we want to return is if that current original string or whatever the stack, right, is empty, then we're gonna return true. So that's gonna be our logic. So I'm gonna declare empty stack list like this, and I'll probably say for parentheses in stack. First scenario we have to think about is left paren scenario, right? So if, for example, P, meaning that whenever we encounter the left sort of the paren here, that's how are we going to express that using this dictionary? If P and match dot values, right? Because all the left-hand parens are stored as values here, value pairs, then we're gonna just append it, meaning that we're gonna just append all those values into a stack. However, meaning that if we encounter the right parentheses, what we want to do is we want to check 2 things. First of all, what we need to check is if there's something on the stack. Definitely, right? We want to check whenever we are encountering the right-hand side of the parentheses, we want to say, is there something in stack or not? If so, what we want to do is is the right parents that we just checked, okay? Is it the same as whatever the latest element in the stack or not? Okay? Meaning, hey, are these two matched together? Do these match together? That's the idea. Then we want to pop the stack out, okay? Else, so let's think about the else here. Why do we have else inside of else? First else is a scenario that we are encountering the right-hand side of these kind of parentheses. Second else is, there are two cases. First, there is, first of all, the negation of the A and B, right? Negation of state. Maybe when we're going to hit this else statement beneath it, when we see nothing on the stack, okay? Maybe some user put some nothing on the stack first or input, right? Or already, if there's like a not matching patterns, then we definitely want to directly immediately return false, because that means we can't pop that out. We can't find any valid parenthesis pair, okay? And at the end of all the for loop, we want to return and check, hey, is the stack kind of empty or not? Okay, that's what we check. So these are sort of the algorithm using stack values, so which I think is kind of pretty straightforward. Let me just recapitulate again. First of all, we're gonna check every parentheses inside this string. If the parentheses in values, meaning that if the parentheses are opening parentheses, then we're gonna add them to our stack. And second scenario is when we're encountering the close parentheses, now we need to take action. We need to check if there's a match or not. But before we check those are match or not in the stack, we want to see if there's anything on the stack. Meaning, if there's nothing on the stack, that means we don't want to append it, because in order for us to find it as like a perfect pair, there's gonna be the left-hand side. There is something on the stack, you know. So, but if that's true, we're gonna pop actually the latest element, right? And let me see. And then otherwise, we're gonna return false. So let's test this code and see if it works. Patterns is not good. Oh, sorry, match. Why am I using patterns here? Match, okay? So that's error. Accepted and submitted. I hope it goes through all test cases. A success. So that was the idea. So you may ask, hey Kevin, why are we pumping it? Because whenever we find close paren there, okay, we just want to pop the previous, the half pair of it. So that was about the solution. I hope you have a great day, and I'll see you next time. Thank you.